All right, now that we have learned 3 different methods to solve systems, one of them being graphing, which is very specific and you can only use when you have a graph, we've learned 2 other methods, substitution and elimination. So in lesson 4 here of Unit 3, we're going to talk about how do we decide which method to use when it doesn't tell us. So we're going to choose our method and we're going to try and figure out what's the most efficient way to solve a given system, either substitution or elimination. So we're not going to learn a new method today, just how do we pick which one to use. All right, so for our warm-up here, we're going to look at this system 3x plus y equals 5 and 8x minus 2y equals 4. And we're going to say, how many different ways could you solve this system? And what would be the first step for each method? Go ahead and pause your video and think about it. So I say that you could solve this system in all 3 methods, right? If I had a graph, I could use graphing to solve it. So I could use graphing, and the first step would be to put each equation into slope-intercept form. But when I look at them, I don't think that would be too hard, right? On the top equation, all I have to do is subtract 3x, so I get y equals negative 3x plus 5. On the bottom, I'd have to subtract 8x, negative 2y equals negative 8x plus 4, and then divide everything by negative 2, but it'll work out really nicely and give me y equals 4x minus 2, and both would be pretty easy to graph. So I have to put both equations into slope-intercept form. Y equals mx plus b. And I'd have to have a graph, right? All right, but I could use substitution. I see that this top equation would be pretty easy to get y by itself. So I could use substitution, in which case I would have to subtract 3x from both sides on the top equation to get y equals negative 3x plus 5. And then I'd be ready to substitute by plugging in negative 3x plus 5 in for y in the bottom equation. So I could use substitution, and I'd only have to move one thing and it would be set and ready. I see I could also use elimination fairly easily, right? I could use elimination by taking that top equation and multiplying everything by 2. If I multiplied everything by 2, I would have 6x plus 2y equals 10, and the positive 2y and the negative 2y would eliminate when I added them together. So I would have to multiply each term in the top equation by 2, and then I would have opposites. So technically all 3 methods would work on this system, and both substitution and elimination would not be too hard. So on this problem, you really could pick whatever method you liked the best. All right, so here we go. We're going to actually, we're going to start by thinking what method would be the most efficient, but then we're going to actually solve these systems as well. So if I look at this system, 3x minus y equals 3, and y equals 3x minus 3, what would be the most efficient? Hopefully you said substitution, because I see that I have y by itself already. So this one is definitely substitution. Remember, you're looking for an x equals or a y equals, or I should be able to do it in one step, right? So that's what we're looking for substitution. An x equals or a y equals, an x by itself or a y by itself. And in this case, I have an x by itself. So I'm going to plug that 3x minus 3 in for y in the other equation. So in that top equation, it'll say 3x minus. Now instead of y, I'm going to replace it with 3x minus 3. Make sure you use parentheses here. This is a sneaky one. Equals 3. Wow, lots of 3's in that equation. Now, it says 3x minus. Remember, there's that invisible 1 in front of those parentheses, so be careful. I'm going to distribute -1 to everything inside here. So 3x minus 3x plus 3 equals 3. I'll tell you, it is very easy to lose that plus sign right there. So be careful that you're distributing a -1 on this problem. All right, now 3x minus 3x. Oh, when I combine my like terms, wait a second. Those cancel out and I get 3 equals 3. Oh my gosh, what is that again? 3 equals 3. Well, that's always true, right? This one would be infinite solutions. Do you remember what a system with infinite solutions looks like on a graph? That would mean that they're touching in an infinite number of places on a graph. This really would be those overlapping lines, right? Or the same line. Just to kind of remember what that looks like. That does work. That is a situation. It does happen. Not a lot, but it does. So don't forget about those infinite and no solutions. We haven't done those in a while. But substitution was definitely the easiest here because the y was already by itself. All right, let's take a look at the second one. Which method would you use to solve this one? Substitution or elimination? -6x plus 4y equals -14. 6x minus 4y equals 10. Oh man, I hope that you are seeing the opposites. In fact, I have opposites in the x, but I also have opposites in the y's. Sorry, trying to get another highlighter here. Positive 4y and negative 4y, those are opposites too. Holy cow. So we definitely would want to use elimination on this one. Oh, my pen's kind of going crazy. Sorry about that. All right, elimination. Remember, you're looking for opposites in one of the variables. Same coefficient. One positive, one negative. That's what we're looking for, right? And I have it already. So -6x plus 6x cancel out. Positive 4 minus 4y cancel out. I'm left with 0 on that side of the equal sign. -14 plus 10 gives me -4. Oh boy, 0 equals -4. That's never going to happen. This is a no solution. All right, do you remember what the lines would look like on a graph if it was no solution? That means that they could never intersect. So parallel lines are the lines that never intersect. And so that does happen as well. Sometimes we have parallel lines, right? And so no solution is a possibility as well. But that one was clearly an elimination problem. You already had those opposites in both of your variables, actually. So this was a double whammy. Okay. Let's take a look at this one. Which method would you use? Substitution or elimination? X plus 3y equals -14. -3x minus 2y equals 14. Now I do see opposites already in the 14s, but those are not on the variables. If I added these two equations together the way they are, I would not eliminate one of the variables. I'd still have an x and a y in my equation, so that's no good, right? So that doesn't count. So we need to make sure that we have opposites in one of our variables. Now, honestly, I see, boy, you could move that 3y on the top equation and have x equals. So you could do substitution in one step. I also see that I could just multiply the top equation by 3, and then I would have opposites in the x. So technically on this one, you could use either method. So which method do you like the best? You choose right now. Why don't you pause your video and solve it? Now, I tend to like elimination the best, probably because you could actually use elimination on any system out there. It always works. Sometimes you have to multiply and get some bigger numbers, but it always works. So I usually do elimination unless it's kind of already set up for substitution. For some reason, a lot of you seem to like substitution, so you could definitely do that. You just have to subtract 3y on both sides and you'd have x equals. But you should end up with the same answer no matter which method you use. I'm going to go with elimination because Well, I don't know. I think a lot of you like substitution. Let's do substitution on this one. So I'm going to subtract 3y from both sides on the top equation. And it will become x equals negative 3y minus 14. So this says x equals, so I'm going to plug negative 3y minus 14 in for x in my other equation. So this is negative 3 parentheses negative 3y minus 14. I'm substituting in for x, so there's no more x in my equation. Minus 2y equals 14. Now I have to distribute my negative 3. I get positive 9y plus 42 minus 2y equals 14. Combine my like terms here. I get 7y plus 42 equals 14. I'm going to subtract 42 from both sides. I get 7y equals negative, let's see, 28. Yep. And then I am going to divide both sides by 7. And I get y equals negative 4. All right, remember our solution to a system is always the point, x comma y, where those two lines intersect. The y coordinate that I just found is negative 4, so I'm going to make sure I put that in the y position. All right, and now technically you can plug back into either equation, right? But when I use substitution, that one that I use to substitute with is always set up for me. So I'm going to go back to that equation and plug into that. So it says x equals negative 3 times negative 4, because I just solved y equals negative 4, minus 14. So x equals negative 3 times negative 4 is positive 12 minus 14. So x equals negative 2. So my solution is the point negative 2, negative 4. So we have now done one of each type of those systems, right? I have infinite solutions with my overlapping lines. I have no solution, my parallel lines. And I have my one solution, my point negative 2, negative 4. And this would come from our intersecting lines, right? Lines that only touch in one place, which is really the most common type of system, is the one where it touches at one point. And remember, that's one solution, two numbers, 1 point, x comma y. Okay, so that one you could have done either method. I did it with substitution, but you definitely could have done elimination on that one as well. All right, let's take a look at number 4. Which method on this system, substitution or elimination? 16x minus 5y equals 17. 8x minus 6y equals negative 2. All right, this one I think it's got to be elimination. I'm thinking there's no way that I could move one thing and get an x or y by itself. No matter what, I'd have to move one thing to the other side and then divide. I also noticed that if I move the 16x on the top and then divide it by negative 5, I would get fractions, negative 16 over negative 5. Ugh. If I move the 8x on the bottom and then divide by negative 6, fractions, right? So this one is definitely elimination. Now, it's not going to be ready right away, but I want to use elimination and make opposites because substitution would give me fractions, and I don't want that ever. So whenever you kind of just scope it out and you say, whoa, there's no way I could do this without getting fractions, do not use substitution. No way. The chances that you get a right answer when you have fractions going on, oh, so slim. So let's see what I need to do to get this ready for elimination. Hang on. That top equation has a 16x, and the bottom equation has an 8x. So all I have to do is multiply that bottom one by a negative 2, and that'll become a negative 16x. So I don't even have to multiply both equations on this one. I only need to multiply the bottom equation by -2. That wasn't even as hard as I thought it was going to be, so elimination is definitely the way to go on this one. So the top equation is not changing at all. 16x minus 5y equals 17, but notice I'm rewriting it to keep myself organized. Please keep yourself organized. Negative 16x when I multiply by -2 on the bottom. Negative 6y times -2 gives me positive 12y equals -2 times -2 is positive 4. Now I have my opposites, so I'm ready to add my two equations together. Oh, sorry, don't write in a highlighter. There we go. Add my two equations together. My 16x and my negative 16x are going to cancel. Negative 5y plus 12y gives me 7y equals 17 plus 4 is 21. Divide both sides by 7. I get y equals 3. So in my point, the y coordinate is 3. And now I can plug back into either equation. It doesn't matter. I don't know, top, bottom, whatever. Let's go top. So I get 16x minus 5 times 3, because I just found that y equals 3, equals 17. 16x minus 15, because I did 5 times 3, equals 17. I'm going to add 15 to both sides. I get 16x equals 32. Divide both sides by 16, and I get x equals 2. So the point where those two lines intersect is the point 2, 3. So remember, if you look at it, if you're scoping it out on which method to use and you see that you would get fractions, if I can't divide by either one of those things, or I would get fractions, don't use substitution. Always do elimination. And this one turned out to only have to multiply one equation to get there, so that's not bad. All right, last problem here. Which method would you use? 10x plus 2y equals negative 26. Negative 4x minus 5y equals negative 19. All right, so on this one, I would go that you could technically use either method, right? You could use substitution, but it would take some work. You definitely could not move something in only one step and be ready. But you could do it in 2 steps, and you wouldn't end up with a fraction. So if you took that top equation, you subtracted 10x to the other side, and then divide everything by 2, you'd get y by itself. And that wouldn't be too hard, and you would not have a fraction. So you could do substitution on this one. I would not suggest trying to get an x or y by itself on the bottom equation, though, because you would definitely end up with a fraction. So don't do it on the bottom. You'd have to use the top equation if you were going to use substitution. Like I said, though, I kind of tend to use elimination because I know it's always going to work. So I think I'm going to choose elimination on this one, but this one would be either one. Oh, I think I said method last time. Either method. But you have to use the top equation for substitution. All right, but you could do it. I'm going to show elimination on this one. The last time we did either method, I used substitution. This time in either method, I'm going to use the elimination. So let's see, 10x plus 2y equals negative 26, and negative 4x minus 5y equals negative 19. So you could get opposites in either x or y. Let's see. Well, if I went to cancel out the x's, I could shoot for the number 20. Multiply the top equation by 2 and the bottom equation by 5. Or if I went to get the y's to eliminate, I'd multiply the top equation by 5 and the bottom equation by 2. So, I don't know. I think I'll go to eliminate. Let's eliminate the x's. So I'm going to multiply the top equation by 2 and the bottom equation by 5. Now you could do this by eliminating the y's. Like I said, there's lots of different ways to do these. Okay, so keeping things organized, top stays on top, bottom stays on bottom. I'll get 20x plus 4y, equals negative 52 on the top. On the bottom, I'll get negative 20x minus 25y equals negative 95. All right, now I have my opposites. I am ready to eliminate. My opposites are these guys right here. Ready to roll. 20x minus 20x cancels out. 4y, negative 25y, I get negative 21y. And now let's see, negative 52 plus negative 95. I get negative 147. And now I have to divide both sides by negative 21. And I get y equals, two negatives make a positive, and it looks like I would have to multiply both. I would get 7. 147 divided by 21 is 7. So I get y equals 7. Here's my point. That's the y coordinate. Plug that in there. Now I need to plug back into either one of my equations to solve for x. And it really doesn't matter. I'm going to go with the top equation because there's no negatives going on up there. So I have 10x plus 2 times 7, because I just found y equals 7, equals negative 26. Multiply 2 times 7, so I get 10x plus 14 equals negative 26. Subtract 14. I get 10x equals negative 40. And divide both sides by 10. And I get x equals negative 4. So you could have done either method, and even if you chose elimination, you could have eliminated the y's first instead of the x's. No matter what method you chose, you should have gotten the same answer, the point negative 4, 7. All right, so just to wrap it up, if you're going to use substitution, look for an x equals or y equals in one of the equations and substitute it into the other, right? So if you have an x equals or a y equals right away, definitely use substitution. If you don't have x equals or y equals to start with, you really should be able to isolate a variable in one step in order to be able to use substitution. On some of them, maybe it takes 2 steps, but remember, never use substitution if you end up with fractions when you're isolating that variable, okay? Elimination, you're looking for opposites in one of the variables, so it's got to be the opposites with either the x or the y. Same coefficient, one positive, one negative. If you don't have opposites, you can multiply one or both of the equations to make them. Elimination works on any system out there. All systems can be solved by elimination. Substitution, don't do it if you're going to end up with a fraction. So substitution is used a little bit less than elimination. All right, choose your methods wisely.